Okay, so again, think about the domain first. And I see two rules of math that will apply. One, there is a denominator, so it cannot be negative. And two, there is a square root, so its contents cannot be negative. So we would be out of the domain if the contents of the square root is less than or equal to 0. It can't be 0 since it's in a denominator, and it can't be negative since it's in a square root. Well, I know that there are complex solutions for this, but we're not dealing with complex variables. So this right here is never going to happen. X squared plus 1 is always positive. You can think about that graphically. It's a parabola. And it is always greater than 0. So we're not breaking any rules of math, so we can say the domain is all real numbers. All right, so now we know where the function lives. We can set it to 0, find the roots, find where it's positive and negative. So setting 3x squared, 1 plus x squared, setting the function to 0, and use the same trick we did earlier. What we do when we're trying to solve an equation for 0 with functions of x in the denominator, we multiply both sides of the equation by the least common denominator. Least common denominator distributed to the first term on the left. The square roots cancel out. You'll be left with that. Least common denominator times the second term on the left. The denominator cancels out, leaving an x to the fourth. And anything times 0 is 0. I think we can factor out an x squared from both terms. All right. So if I take an x squared out of this first term, I will be left with the 3 and the x squared plus 1. If I were to take an x squared out of this second term, I would be left with an x squared. Distribute your 3. Collect like terms. Now we're going to set each factor to 0. And we get x is 0. Set the second factor to 0. And we get no solution for this. Again, this is a parabola that lives entirely above the x-axis. If we were to try to solve for 0, we would have to solve for where x squared is equal to negative 3/4, and this just has no solution. So x equals 0 is the only root. So it's the only thing that goes on the number line. All right, so pick something less than 0. I choose negative 1. We plug negative 1 into this, we'll get 3 square roots of 2. Negative 1 to the fourth is positive 1. So we get some positive number. Choose something bigger than 0. I pick 1. If x is 1, we would get 3 from here times the square root of 2. If x is 1, our numerator is 1, and the denominator is root 2, and so again we see it's positive. So our function is greater than 0 from negative infinity to 0, union 0 to infinity, and no, you cannot condense that into one interval.